wanted to demonstrate how this frequency analyzer can be used with our simple sensor output of the speaker. And so what I've done is I put a smaller capacitor in the input of the C, 100,000 ohms here in the R, and instead of a fixed resistor, I'm putting that into a variable resistor or a resistance substitution box. I'm only doing that for the video, but you can use actual values of resistances here instead of the resistance box. This is just to create a standard value. So as I hook this up, we start with 560 hertz on our scale here, and we have 15,000 ohms. Now I go down to 22,000 or up to 22,000 ohms, and we see that the frequency is changed to 538. 33,000 ohms, the frequency goes to 510 or so, and then 47,000, 430, 68,409, and finally 100,000, about 366. So, what can we do with that data? I put that into what's called a nomograph, which plots the data, and it compares it by the resistance on one axis to the frequency on another axis. And if you plot the lines, you can see that it's pretty much a straight curve. If I was a little more accurate or a better graph paper, I'd probably do a better job of this. Let's suppose we have an unknown resistance and we connect it instead of our resistance substitution box. Then what we could say is, if it had a particular frequency, I could put it up on the graph and note what actual resistance it would correspond to. So this is the way that some meters work, where they actually have a chip that decodes frequency to resistance or various other kinds of values in electricity.